We are literally standing at the threshold of a computing revolution. The quantum space has recently experienced a surge in investor interest, with funds flooding into publicly traded stocks. These big names, Meta, Google, Microsoft, Amazon, have gained billions of dollars in value during the last year. Over the last 6 months, the scale at which this development is happening is unbelievable, transitioning from a research project to the early stages of an engineering phase, which is really exciting. Part of the excitement stems from the expected long-term benefits. McKinsey estimates that quantum might be a $173 billion market by 2040. The market is now worth almost $500 million. We believe that figure might climb by a factor of 5 or 10, depending on how companies implement mistake correction at scale. So by the end of the decade, the market size would be between $2.5 and $5 billion. A quantum computer is capable of solving highly complex mathematical problems. Additionally, chemistry is another area that aligns well with the strengths of quantum computing. There are aspects of optimization and logistics that Amazon would be particularly interested in. What this means for Amazon is that they have the opportunity to build a supercharged version of AWS that can solve incredibly difficult problems, whether they are related to drug discovery or cybersecurity, and charge a lot more for it. However, we are still years away from a functioning quantum computer, with estimates differing greatly. NVIDIA CEO Jensen Huang has stated that practical quantum computers could be 15 to 30 years away. Although Google claims commercial quantum applications are only 5 years away, IBM predicts 2033. I think that within the next 5 years, we'll begin to see demonstrations of this for materials design or chemical difficulties. And then, within a decade, I believe we may develop highly fault-tolerant quantum computers capable of solving many of the problems we seek to solve. One challenge in quantum computing is that these systems are difficult to scale. They are highly sensitive to interference from their environment, which can include vibrations, heat, radiation, or even the Earth's magnetic field. To address this issue, a large barrier made of a specialized metal is used to attract the magnetic field and isolate the quantum processor situated at the bottom of the freezer. However, the major drawback of quantum computers is inaccuracy. Researchers have mostly focused on recognizing and then correcting for them. These computers have a high mistake rate. If you can eliminate the faults in these quantum computers, you will be able to turn it into a viable technology. And we are already entering that period. That is why you are hearing so much about all of these breakthroughs in the sector. And that's very thrilling. It's a significant paradigm shift, but you now need to make that error correction even more efficient. You must encode the information that it processes in a highly redundant manner, so that when errors occur, they do not affect the information that you are attempting to safeguard and process. The mistake rates remain so high that they are no longer commercially feasible. But we'll see some leapfrogging. Who is involved in the race to perfect quantum computers? And the answer is everyone. All of the major players are involved in this competition. Otherwise, Silicon Valley could become the new Rust Belt. In addition, quantum computers are appealing to everyone interested in security. They can break practically any code based on digital technologies. That is why the FBI, CIA, and all national governments are actively monitoring the situation. Quantum computers will transform everything, including the economy, problem solving, and our interactions with the universe. You name it, quantum computers will be present. Initially, there were no computers. Geometry and astronomy were particularly time-consuming. So, you've got your small pencil and paper, and are wandering across the mathematical map. It was slow, and there were many areas that we couldn't investigate because they were outside our computational capabilities. But then we built early computers, which allowed us to input greater datasets and solve previously unsolvable issues. So the journey starts with Charles Babbage's work. He builds the ultimate analog computer, using hundreds of gears, levers, and pulleys. Turning the crank allowed you to determine longitude, latitude, and interest rates. It was quite valuable to have such an instrument for the financial industry and commerce. Then World War II occurs. Babbage's machine was just too basic to break the German code. Therefore, the task was assigned to mathematicians such as Alan Turing. Alan Turing was responsible for codifying many of the laws of computation into what is now known as digital. Transistors now serve as the foundation for the digital revolution. It works with zeros and ones at the speed of electricity. Each digital computer is a Turing machine. The quantum era represents the next level beyond digital computing. Richard Feynman was both a pioneer of quantum electrodynamics and a visionary, and he posed himself a basic question: how small can a transistor get? And he understood that the ultimate transistor is one atom capable of controlling the flow of electricity in all directions, not just on and off. We must turn to quantum computers, which calculate on atoms rather than transistors. Transistors are built with zeros and one. Reality is not. Reality is founded on electrons and particles, which act like waves. So you need a new set of mathematics to discuss the waves that make up a molecule, which is where quantum computers come in. They are based on electrons. But how come these electrons have so much processing power? Because they can be in two places at once. Quantum computers are powerful. They compute over an infinite number of parallel universes, rather than just one. At its most fundamental, quantum physics can be simplified to a cat, namely Schrödinger's cat. Let us take a box. You put a cat in the box, and the question is whether it is alive or dead. You won't know until you open the box. It lives and dies at the same time. It exists in two states at the same time. In other words, the universe is divided in half. The cat is still alive in one universe. In the other universe, the cat has died. That is the premise of quantum theory, which claims that the cat can exist in both states at the same time, or in any number of states at the same time. Until a measurement is taken, the cat could be dead, alive, playing, jumping, lying sideways, sick, or in any other situation. So, this shows the capabilities of quantum computers. Quantum computers operate in parallel universes. That's why they are so powerful. So how much faster is a quantum computer than a digital computer? In principle, the power of digital computers can be measured in terms of bits, spin up, spin down zeros, and one make up one bit. For a huge digital computer, we're now talking about billions of bits modeled by transistors, but quantum computers talk about everything in between, which is known as a qubit. One qubit represents all of the possibilities for an item spinning up and down. The most advanced quantum computers can now model thousands of qubits. Eventually, we aspire to reach 1,000,000. So we're talking about going beyond the power of typical digital computers. It is the point at which a quantum computer may outrun and surpass a digital computer at a given task. You know how when you explain anything to a 2-year-old, they simply keep saying, "Why?" But you have to explain it again, and they go, "Why?" As the computer's controller, how do you decide on such probabilities? Essentially, you're changing the probability as you execute an algorithm. It is a popular misperception that quantum computers try all the options. This is not true. This is oversimplified, but it's more like a quantum computer watching the pond. It observes how all of the waves interact and then determines the most likely answer. If this all sounds confusing, don't worry. All you really need to know is that quantum computers calculate things quite differently than classical computers, which allows them to excel at certain tasks. Quantum computers will not be faster at everything than classical computers, so it's not good for addition, right? Because your calculator and phone are excellent at it. However, quantum computers are particularly adept at detecting structure in massive amounts of data. The most serious issue confronting quantum computers is decoherence. Everything is made up of particles such as electrons, which have waves connected with them. When these waves vibrate in unison, this is referred to as coherence, and it allows you to perform quantum mechanical calculations. But if you lose coherence, everything vibrates at a different frequency. That is called noise. You must drop the temperature to near absolute zero so that everything vibrates slowly and in unison, which is challenging. Nature now solves this problem. It serves as the foundation for all life on Earth. Photosynthesis is a quantum mechanical process. Mother Nature can generate coherence at ambient temperature. Amazing. Mother Nature is still smarter than us in terms of quantum theory. So let's face it, there are obstacles to the growth of quantum computers, although they are minor in compared to the benefits that quantum computers may provide. We are talking about opening the floodgates. Take, for example, the food supply. The green revolution, which allows us to feed the world's population, is gradually coming to an end. We're trying to use quantum computers to figure out how to create nitrogen fertilizer. Take a look at energy. Quantum computers may be used to generate fusion power by stabilizing the superheated hydrogen within a fusion reactor. Take a look at medication. You comprehend that life is made out of molecules, which can cause Alzheimer's, Parkinson's, and cancer. These diseases are beyond the capabilities of digital computers. But hey, that's what quantum computers do. In conclusion, while the journey to fully functional quantum computers is fraught with challenges, the potential rewards are monumental. As we stand on the brink of this technological revolution, the applications of quantum computing promise to reshape industries, from agriculture to energy and healthcare. By harnessing the unique capabilities of quantum mechanics, we can tackle some of the most pressing issues facing humanity today. The future is bright, and as we continue to innovate and overcome obstacles, the possibilities for quantum computing are truly limitless. Thank you for watching the video. If this video was helpful to you, please like, comment, and share it with your friends. Subscribe to our channel and click the bell symbol to get more videos like this in your feed.